Here's Ms. Seals back for our second science lab of the school year. Last week, we started talking about what we called physical properties of matter. And I want you to remember that a physical property is anything that we can measure, observe, or test out or describe about matter. And remember, matter is anything around us that takes up space. Last week, we talked about the physical property called physical state, and that means when we classify matter as a solid, liquid, or gas. Remember, I made the GAC, and then you had to decide based on its characteristics if it was a solid, liquid, or gas. You were describing its physical state. Today, we're going to be talking about a second physical property, and this one is called relative density. So I will explain what that is in just a minute. Right now, I want to read your target to you that says, I can classify matter based on measurable, testable, and observable physical properties, including relative density. So, you're probably wondering, Miss Seals, what is relative density? So let's talk about it. I have two pictures here. Maybe if you look and think, maybe they might give you some clues as to what relative density is. There's your target again. I can classify matter based on measurable, testable, and observable physical properties, including relative density. So what is relative density? Density has to do with how tightly packed the molecules in an object are. So if the molecules in an object are tightly packed, it would be more dense than an object where the molecules are more spread out or less tightly packed. There's a formula for actually calculating and determining density, and that's when you measure the mass, you measure the volume, and then you divide mass divided by volume. In 5th grade, you do not need to know how to do that. We're not going to be measuring density and calculating density. But the reason I'm telling you that formula is because I want you to know that it has to do with the mass of an object, which is how much matter is inside, and the volume of an object, which means how much space an object takes up. Okay, so again, that goes back to how tightly packed the molecules in an object are. So relative density is an object's density in relation to water. So in other words, if we put it in water, is it going to sink to the bottom or float? That's all relative density is. Hopefully sinking and floating sounds familiar to you. We did sink and float in 3rd grade and 4th grade if you were here at Pershing Park. Objects that are less dense than water will float. Objects that are more dense than water will sink. Okay, so what you need to know right now is that relative density is referring to an object's density in relation to water. If we put it in water, is it going to sink or float? All right. Here are some objects that are less dense than water. We have wood. We have a sponge. We have styrofoam. We have a ping pong ball. All of these objects are less dense than water. That means their molecules are more spread out or less tightly packed than the molecules of water. I can tell by looking at these pictures that all of these objects are less dense than water because they're all floating on top of the water. Remember, objects that are less dense are going to float, okay? Things that are more dense than water, a glass marble, an eraser, a rock, and a golf ball, okay? All of these objects are more dense than water, so their molecules are more tightly packed than the molecules of water, and that causes them to sink to the bottom because they're more dense. Today we are going to explore relative density with 5 different liquids. So all the things I just showed you on the previous page, those were solids. Today we're going to find out which liquids are more or less dense than water. All 5 liquids will be poured into a graduated cylinder, and we will be able to easily see which liquids are more dense because they will stay at the bottom, and the liquids that are less dense will go to the top. So the end result is what's called a density column, because we're going to have all the liquids in a graduated cylinder stacked on top of each other, easily being able to see which ones are less dense and more dense. Okay, so this is what I'm going to do now. I'm going to stop sharing my screen. So you're looking at me again. I'm going to talk to you about the 5 liquids that we're going to be using so that you're familiar with them and know kind of what they do, what they look like. And then you're going to be making a hypothesis in Schoology. And then you're going to be coming back. I'll make the density column, and then we'll talk a little bit about what that means, and then you'll finish your assessment in Schoology. Okay, so the 5 liquids that we are using. The first liquid that we are using is called glycerin, and this is probably something that you are not very familiar with. I wasn't very familiar with this. I had to actually look up what it is, and it's used in lotion and skincare. It's kind of a moisturizer. It soothes skin. It's good for your skin and your hair and all of that. So people who might make their own lotion or their own soap or their own shampoo even might put glycerin in it. It normally is not this color. It's normally clear, but I put food coloring in it to make it this color so that we will easily be able to see it in our density column. All right, so this is our first liquid called glycerin. And I'm kind of showing you what it looks like as I turn it. So maybe that is some information you can use to make your hypothesis. Since remember last week, I told you how when a scientist makes a hypothesis, it's an educated guess. So you're going to be using what you see, what you know to make your hypothesis. All right, that's the glycerin. The next liquid that we'll be putting in our density column is corn syrup. It comes in a container like this. Corn syrup is basically just like liquid sugar. It tastes very, very sweet. It's used for cooking. It's used for baking. It's very thick. Notice how it moves as I turn the bottle. Okay, it's not watery and runny. It's thicker. It moves kind of slowly. All right, so that's our corn syrup. The next one is dish soap. All right, just regular dish soap you would use to wash your dishes. Sometimes it's different colors. This one actually came this color. I didn't put any food coloring in it. Okay, it's this reddish color. The next one is vegetable oil, also used for cooking. All right, it's kind of this light yellow color. Notice how it moves as I tilt the bottle. All right, and then the 5th liquid that we will be using is just regular water, and I have put blue food coloring in it again so that we'll be able to easily see it in our density column. Okay, so those are the 5 liquids we'll be putting in our density column: glycerin, corn syrup, dish soap, vegetable oil, and water. So this is what I would like for you to do right now. In just a second after I give my directions, you are going to pause this video. You're going to go back into Schoology where you found this video, and there is a spot where there is a discussion post. This is where you're going to make your hypothesis, okay? I would like for you to make a hypothesis about which of these 5 liquids do you think is the most dense. So in other words, which one of these 5 liquids do you think is going to stay at the bottom of our graduated cylinder once we have all of our liquids poured in. The one that stays at the bottom is the most dense. So you're telling me which one you think is the most dense, and you're explaining why. So I want you to think about what I talked to you about density. Think about what you saw when I was moving the liquids around. Think about some things you've already seen or done before, and use that to make your hypothesis, okay? You're just telling me which one you think will be the most dense and why. After you have done that, you're coming back to this video, pressing play, and I will do the experiment for you. All right, so I'm gonna hold this up so you can see the names of the 5 liquids so you don't forget. Again, we have glycerin, corn syrup, dish soap, vegetable oil, and water. So go ahead and pause this video now. Go ahead and make your hypothesis in Schoology and then come back. I'll see you in a second, okay? All right, hopefully you were able to pause it so you could see these names if you needed to. So we are ready to make our density column. Remember that whenever I'm doing a demo for you on here, this is just a demonstration. You are just watching. This is not something for you to do at home unless you have permission from an adult who says it's okay. Even though none of these liquids are dangerous and none of them will hurt you or make you sick, it still is, it can get very messy, and you're still using some things that your parents have spent money on, okay? So I don't want you to make your own density column unless you have permission from a parent. Do we understand? All right. So here is my graduated cylinder. I'm going to get it nice and close so you guys can see. The first liquid I'm going to add is the glycerin. Now, before I start, I want to talk about one more thing. I've added all of the liquids into these little beakers, and I made sure that I'm using the same amount of each liquid. I'm using 100 milliliters of each liquid. Why do you think I'm using the same amount of each liquid? Why can't I just pour them all in here and see what happens? Well, it's a word called variable. When a scientist is doing an experiment, there can only be one variable, and a variable is the thing in an experiment that changes. Okay, you can only have one thing that changes, and here's why. Did I talk about this last week? I don't think I did with 5th grade. If I did, you'll get it again. So our variable in this experiment is the type of liquid. That's it. That's the only thing I can change, because if I had 2 variables and I was changing the type of liquid as well as different amounts of the liquids, I don't know if my results are accurate. I don't know if my results are because that liquid truly is the most dense, or maybe it's just because I used more of it. Okay, this way with one variable, I know that my results are accurate. I'm using the same amount of each type of liquid, so the one that stays at the bottom will truly be the one that is the most dense. All right, okay, got that out of the way. Now, I am trying to be careful not to make a big mess. If you know Miss Seals, things get messy. All right, first liquid I'm adding is the glycerin. So right now you are just watching. You don't need to be doing anything else. You're not going back into Schoology and changing your hypothesis. It doesn't matter if your hypothesis is right or wrong. You're just watching. All right, so here's the glycerin. I'm gonna kind of tilt my graduated cylinder so that it doesn't make a big mess. Try to get all of it out as I can. There's my glycerin. I noticed that the glycerin was moving kind of slowly. Seems like it's a little bit thicker than maybe some of the other liquids. All right, so there is our glycerin. The next thing I'm going to add is the corn syrup. Remember, that's this one. This is the corn syrup. You're still just watching. Trying to get as much as possible. I know it's hard for you to see, but I'm going to hold this up so you can see a little bit better. What are you noticing? Do you see how up here it's darker than it is right here? Do you see that line? Okay, what's happening is the corn syrup is pushing its way down underneath the glycerin. Okay, that's why it's lighter down here. They kind of mixed together when they were up here, but after the corn syrup got in there, it's starting to push down through the glycerin. Remember, my corn syrup is that kind of light yellow color, so it's a much lighter color than the glycerin. That's why you see that line. Below that line where it's lighter, that's the corn syrup. Above that line where it's darker, that's the glycerin. So right now, so far, we could say that the corn syrup is the most dense. It's more dense than the glycerin. And I can tell that because it kind of pushed and fought its way underneath the glycerin to the bottom. So right now, the corn syrup is the most dense. The glycerin is less dense because it's at the top. Interesting, huh? All right, our next liquid is the dish soap. That's pretty interesting. Can you see? So the dish soap is on top of the glycerin. So that means the dish soap is less dense than the glycerin or the corn syrup. We know that because it's floating on the top, all right? The corn syrup is still the most dense. It's staying put on the bottom. And I know that because it's all the way at the bottom. All right, let's keep going. Our next one is our vegetable oil. All right, so look at that. Our vegetable oil sitting on top of the dish soap. So far we have the vegetable oil at the top. It's the least dense. Then we have the dish soap, the glycerin, and the corn syrup. The corn syrup is the most dense so far. We have one more liquid to add to our density column, and that is the water. Remember, it's just water with blue food coloring in it. Make sure you're watching carefully. This one's really cool. Are you ready? Give it a minute to kind of settle. What do you notice? What's happening? Can you see that the water, let me get away from the window, maybe that'll help. The water, remember that's our blue one, is pushing its way down underneath the oil, okay? Because oil is less dense than water. A lot of people don't know that. A lot of people think about oil and think that it's very thick and kind of heavy. And so they think it would be more dense than water, but it's not. Oil is actually less dense than water. So in our density column at the top, the least dense liquid that we have is the vegetable oil. Then we have the water right here. It's kind of mixing in a little bit with the dish soap, which is right below it. Then we have the glycerin, and then the most dense, still hanging out there at the bottom, is the corn syrup. So in our density column, I'm trying to make it so you can see a little bit better. In our density column, the vegetable oil was the least dense, and the corn syrup was the most dense. We know that the vegetable oil is the least dense because it's floating on top of all the other liquids. We know that the corn syrup is the most dense because it sank to the bottom and it's below all the other liquids. All right? Pretty cool, huh? So this is what I would like for you to do now. When this video is over, you are going back into Schoology. There is a short little assessment to see what you learned, what you know about relative density. This is not for a grade, okay? It's just for Miss Seals to see what you learned, what you understand about relative density. So I know what I need to keep teaching or what I need to teach differently, okay? Just do your best, and I hope you guys had fun, and I will see you in Science Lab next week. Bye-bye.